Okay, let's take a look at our next lesson in our video. Let me get everything turned on. As you know, we've been working in Unit 3, Chapter 1, Inductive and Deductive Reasoning. So by now you're starting to get a feeling for the differences between inductive and deductive reasoning. Inductive reasoning being we see many examples of something, make a conjecture about the pattern that we see. And every time we come up with a new example that supports this, we're adding strength to our conjecture. But we know that we cannot prove anything with a conjecture when we're using inductive reasoning. When it gets to deductive reasoning, we are actually setting out to prove something conclusively. And so today we're going to be looking at how do we know when a proof is no longer valid? And what we're going to be looking for are some of the common errors that we find in proof writing. So the vocabulary I want you to be watching out for is invalid proof, premise, and circular reasoning. Make sure that you take note of those as we go through this video. So the big thing to keep in mind is that it only takes a single mistake in reasoning, and that will break down the logical argument of a proof. That's similar, isn't it, to conjectures? Conjectures only need one counterexample, and we can have thousands of examples that work, but only one counterexample, and the conjecture is invalid. Similarly, in a proof, you can say all kinds of true things all around it, but you make one simple mistake, and it's considered an invalid conclusion. So, what are some of the common errors that we see? Well, errors in calculation would be one of the first ones. Now, this can be anything. This can be someone forgot to distribute a negative, they forgot to distribute a number 2, they've added things incorrectly, they've done any number of algebraic errors. But the big one that we want you to watch for is division by 0. As you know, dividing by 0 is something that we cannot do in our mathematical system. And in fact, mathematicians are quite distraught about dividing by 0. It's a bit of a stepping on the edge of a cliff and looking out over the precipice when we think about dividing by 0. And so there are lots of jokes sort of thing online about that. Division by 0, don't even try it. The world falls apart. Or it opens up this great black hole in the universe. Or this joke, just give him whatever he wants. He's threatening to divide by 0. All right, the next thing is circular reasoning. Now, this is a little more subtle, a little harder to see. But basically, you cannot assume a result. So you cannot come to a proof, the end of a proof, that comes from something that you're trying to prove. Now, that sounds very funny, and I think we're going to need to see some examples to see it. But if you're trying to prove one thing, make sure that you don't assume it's true in order to prove it, because you are basically using the thing you're proving in your proof, and that makes no sense at all. So circular reasoning is something that goes around literally in a circle. So this is a good example. I need a car so I can work, but I need a job so I can get a car. So you can see this person is they're stuck in a circle. They need a job um, before they can get a car, because in order to pay for it, but they also need the car to get to work. And so they've got this circular problem going on that really has no solution in itself. Here's another one. Why should I go to college? So you can get a degree. Why? So you can get a good job. Why? So you can make more money. Why? So you can pay back your college loans. Or this comic, graph A is verified by graph B. Graph B is verified by graph C. Graph C is verified by graph A. So you see, it's all verified. And if you think about what he's saying, none of those graphs have actually been verified by something that is conclusive. They've just depended on each other. And if one of them was not true, then the whole thing would fall apart. So you have circular reasoning going on in this one. And one last one. What is the key to success? To hire the right employees. How do you know you hired the right ones? You know because the business is successful. So the key to success is circular reasoning? Yes, because circular reasoning is the key. So a bit of a, always tongue-in-cheek when people are talking about circular reasoning, it's a bit of a make your head spin kind of logic, the chicken and egg argument, if you will. So the third one I want to say is just confusing reasoning. Reasoning that just you look at it and think, that does not make sense. There is something completely wrong there. This is just one that's poking fun at that one. False proof. Can you spot the mistake? 3 is equal to 0. Well, clearly it's not hidden. It's hidden in plain sight, as we would say. 3 is not the same thing as 0. And so it's just something that is just doesn't make sense. This one is one of my favorite ones. It says, I think you should be more explicit here in step 2. You can see that he's got all kinds of mathematical stuff going on the left and mathematical stuff on the right, but somewhere there's this break, this bridge. And that's where the miracle occurs in order to make the two connect. So I want to take a look at a couple of simple examples so you can get a feeling for what you're going to see in your homework. So let's take a look at this one. Zach is a high school student. All high school students dislike cooking. Therefore, Zach dislikes cooking. If you're really paying attention to this, hopefully you can see that this is an example of the transitive property. Zach is a high school student. That's A is equal to B. All high school students dislike cooking. So that's B equals C. And so then they put it all together that A equals C. So Zach dislikes cooking. Now, of course, this one falls apart. And really it falls apart because of the middle statement where they're making a generalization that is not true. And basically, it's like a stereotype. And one of the things you should remember is look for those because stereotypes always fall apart because there is always a counterexample to cross them. You can't really say that all high school students dislike cooking. There's always someone who is the exception to that rule. And so that's why this use of the transitive property or logic breaks down. Now, before we do the next one, I just want to make sure that you've seen the word premise before. Premise is a statement that's assumed to be true, kind of like that generalization that we started with when we were talking about proofwriting in the last lesson, a premise. So it's kind of like this one. Bev claims that he can prove that 3 is equal to 4. So he makes a premise, A plus B equals C. Now, we don't know what A is, we don't know what B is or C, but we can take this at face value and just say, okay, if you tell me that A plus B is equal to C, that's where we'll start. Now, what he claims that he will be able to prove is that 3 is equal to 4. So if you take a look at what he's done, first of all, he's split apart the terms. So instead of calling it A, he called it 4A minus 3A. Of course, that's the same thing as A. And then he called this one 4B minus 3B, which is the same thing as B. And 4C minus 3C, the same thing as C. Now, of course, you're wondering, what on earth is he doing? Well, if you look at the strategy, he's trying to get some 4s and he's trying to get some 3s around. And what he decides to do next is let's put all the 4s together. So 4A plus 4B minus 4C. And then let's do the A's, or 3s, sorry. And so he puts the 3 over there, the 3B over here, minus 3C. And then he decides that he's going to factor out a 4. 4 onto A plus B minus C. And the same thing with the 3. And then he's dividing by A plus B minus C on both sides. And he gets 4 is equal to 3. So the question is, where did he go wrong? Where is it? Like, this row is fine, check. This row is fine algebraically. This one where he factored is okay. But something happened here. And if you stop and look at it, something went wrong from here to here. Let's consider what he did. He divided by A plus B minus C on both sides. And if you look up at above and think of it, A plus B minus C is equal to 0. So he has divided by 0, which is impossible mathematically speaking. So his proof doesn't hold tight because he has made this error in his reasoning. Next one, example 3. Liz claims that she can prove that negative 5 equals positive 5. And so here you go. So she assumes negative 5 equals 5. And then she decides, okay, I'm going to square both sides. So I square this one, square that one, and I get exactly the same number. So I must be saying something that is true. Since this is true, my original statement is true. Well, the problem is that she starts with a premise or an assumption that is false. And she's also taking what it is she's trying to prove and starting to say that this is true to begin with. But you can't do that because this is what you're trying to prove. So you can't start by saying it's true. This is that circular reasoning problem that we have talked about a little bit. Okay, so there you're introduced anyway to a few of the errors and proofs. And so you'll need to try these homework examples to make sure that you've seen some of the proofs in action. So good luck, and remember, bring your questions to class tomorrow.